All right, so I'm gonna be going over the second part of the basics to Game Hacking Academy. So, while games are applications, they are complex and made up of several parts, and these include graphics, sounds, input, physics, game logic. Due to each part's complexity, most games use external functions for these parts. The external functions are combined into what is called a library. Libraries are then used by other programs to reduce the amount of code written. For example, to draw images and shapes to a screen, most games use either the DirectX or OpenGL library. For some types of hacks, it is important to identify the libraries being used. A wall hack is a type of hack that allows the hacker to see the other players through solid walls. One method of programming a wall hack is modifying the game's graphics library. Both OpenGL and DirectX are vulnerable to this type of hack, but each require a different approach. For most hacks, we'll be modifying the game logic. This is the section of instructions responsible for how the game plays. For example, the game logic will control how high a character can jump, or how much money the player receives. For changing this code, we can potentially jump as high as we want, or gain an infinite amount of money. Game structure. Game logic is made up of instructions like all computer code. Due to the complexity of games, they are often written in a high-level language and compiled. Understanding the general structure of the original code is often required for more complex hacks. Most games have two major functions, setup and main loop. Setup function is executed when the game is first started, responsible for loading images, sound, and large files from the hard drive and placing them in RAM. The main loop is a special type of function that runs forever until the player quits. It is responsible for handling input, playing sounds, updating the screen, among other things. An example main loop might look like this. So function main underscore loop. So this is obviously written in assembly, right? Or is it? This looks like C++ actually. Function main underscore loop. Then the loop we have handle underscore input, update underscore score, play underscore sound, underscore effects, child underscore sound. Yeah, function, okay. All these functions in turn call other functions. For example, the handle underscore input function might look like if key down equals left, update player position, go underscore left. If key down equals right, update player position. Okay, every game is programmed differently. Some games might prioritize updating graphics before handling input. However, all games have a main loop of some sort. Data in classes. Any data that can be updated in the game is stored in a variable. This includes things like player's score, position, or money. These variables are declared in the code. An example variable definition C might look like int money equals 0. This code would declare the money variable as an integer, like we learned in the last lesson. Integer values in C are whole numbers like 1, 2, or 3. Imagine if we had to track the memory for several players. One way to do this would be have several declarations like so. Int money 1 equals 0, and money 2 equals 0. Okay. One downside of this approach is that it is hard to maintain as the game gets larger and more complex. For example, to write code that increases every player's money by 1 to manually update each variable. If we add another player, we would have to go and update every section of code that altered the player's money. The approach is to declare these variables in a list. You can use them in an instruction known as a loop to go through every item in the list. This is known as iteration. In C, lists are commonly implemented using what is known as an array. For our purposes, you can assume lists and arrays are synonymous. One type of loop in C is known as a for loop. For loops are divided into 3 segments: the starting value, the ending value, and how to update the value after each iteration. Example of the previous code might be written like int array money with 10 okay, this is signing an array, 10 thing array. Wait, okay, this is setting the 10th item in array is equal to 0. Int current player is equal to 4. So increase money for int I. So for index of I is equal to 0. As long as index of I is less than the current player, as long as it's less than 4, increment I by 1. Money I is equal to money I plus 1. So this is saying money at index of I is equal to money at index of I plus 1. Setting that over and over again. We now would only have to update the current underscore players variable to add support for another player. Make it easier to develop complex applications. Developers often use a programming model known as the object-oriented programming, or OOP. In OOP, variables and functions are grouped together into collections called classes. Classes are usually self-contained. For example, in many games, I have a player class. Class will contain several variables like the player's position, name, or money. These variables inside the class are known as members. Classes will also contain functions to modify members. One example of a player class might look like class player, integer money, string name, function increase underscore money, money equals money plus one. Games will often contain lists of classes. For example, the game Quake 3 has an array of all the players currently connected to a server. Each player has their own player class in the game. To calculate the score screen, the game will go over every player in the list and look at the amount of kills they have. Memory. Games have a lot of large resources like images and sounds. These must be loaded into the hard drive, usually in the game's setup phase. Once loaded, they are placed in RAM along with the game's code and data. Because games are so large, they must constantly load different data from the RAM to registers to operate on. This loading is typically done by a move command. This command will move a section of memory into a register. Our increase underscore money example function executed by the CPU might look like function increase underscore money. Move this fucking value into EAX. Add 1 to EAX. Move EAX. Move EAX into this. Example, we use 0x whatever location of RAM of the player's money. Most games will have the structure by a different location. More complex games' locations will be the structure by different locations. For more complex games, locations will be based on locations where a game had a player class increase underscore money code. The CPU would need to use the player class's location to retrieve the money. So function increase underscore money moves this into EVX. Moves over 8 bytes. Or 8 bits. 8 bits or 8 bytes? I think it's 8 bits. I don't know. I can't remember. So it adds the CPU had to offset the money's location. This is what I'm talking about offsetting the money's location right here. So it's the money's location is EBX plus 8, so it's assigning that to EAX, adding 1 to EAX, and then assigning EAX back to EBX plus 8. So it's putting this in EBX, and then putting the offset, which is plus 8, to where the money is, and then moving that to EAX, adding 1 to it, moving it back into EBX. In this case, CPU had to offset the money's location based on location of the player class. Okay. Multiplayer games allow multiple players to interact with each other. To allow this, multiplayer games make use of clients and servers. As an example of the client server model is shown below. The server, and this is guys go in and out connecting. Clients represent each player's copy of the game and contain all the information regarding the local game. For example, each client will contain that player's money. If the player calls an action to change the money, the client is responsible for sending the update to the server. Information can also be sent in both directions. An example of this is the player's movement. One client will tell the server that the player has moved their position. The server will then tell all other clients to update their associated positions for the moved client. Multiplayer servers. When the client represents each player's copy of the game, the server ensures that all the connected clients are playing the same copy of the game. The servers will often restrict what changes they accept from clients. For example, imagine we wrote a hack to change our memory in game. If it is a multiplayer game, the server will reject our changes. This is why single player hacks often not work in multiplayer. Discuss multiplayer fundamentals further in a future lesson. Alright, that's the end of this fucking module.